Hello, I am Thouraya Guesmi, a PhD student. So today I am going to present my article named Effective Connectivity of High Frequency Oscillation Using Different Source Localization Technique, supervised by Dr. Abir Hadriche and Dr. Nawel Jmail. First of all, I will present you with the following work plan. The brain is an information processing system that can comprise about 8 billion neurons. So, to understand the function of this organ, it's necessary to understand the neuronal mechanism and their interaction, which are reflected in potential differences interpreted as electrophysiological signals. They are severe neurological diseases that affect the human brain. Among these pathologies, we find Alzheimer, brain tumor, Parkinson, and we are interested in epilepsy. So, epilepsy or crisis is an abnormal electrical discharge of neurons in their cerebral cortex. We have medical treatment can be stopped and about this crisis effective in 70% of situations, but in the rest there was no remedy, hence the term drug-resistant epilepsy. So for drug-resistant patient, surgery is necessary to remove the primary seizure zone called epileptogenic zone. This localization of the epileptogenic zone is based on a wide range of modalities, such as the analysis of electrophysiological signals, which are the electroencephalogram EEG, which collects electrical signals from the scalp in a non-invasive way, and the magnetoencephalogram MEG, which presents surface signals of magnetic origin in no traumatic way. And the second way of recording that I use in my work called intracerebral EEG, which collects signals directly from neuronal assemblies via electrode implanted deep in the brain. The pre-processing of these cerebral signals proves the presence of certain oscillation delimited by specific frequency bands. We have high frequency oscillation, HFO, are considered as effective tools to identify cognitive status and severe cortical disorders like epilepsy, since they are appear in epileptogenic region during the acquisition of epileptic brain activities. So we can say HFO are considered biomarkers of epileptogenic zone. So, all processing steps were applied on MATLAB, MATWORK, and Brainstorm Toolbox. In this study, I worked on two types of database, simulated and then two real intracerebral electroencephalogram recordings. One of combined high-frequency oscillation and spikes, and the other of pure high frequency oscillation that I have detected in previous studies. For methods, I propose to use surface measurement and source localization to determine the neural generators responsible of the successive discharges. Since source localization consists in estimating from surface measurements the location of the neural generator responsible for a given waves. But this technique it requires a direct and inverse problem. For direct problem, I use default anatomy of brainstorm. But about the resolution of inverse problem, we have the following techniques. However, I focus on distributed methods which are characterized by a high number of dipoles are distributed in the whole head or in cortical part. Remain within the framework of solving the inverse problem. The distributed methods we have applied are MNE, S-Loretta, and DSPM, which each has its own properties. This schematic is the diagram of defining networks connectivity steps. An automatic reconstruction of the paired high-frequency oscillation was performed. Then a source localization was performed by solving the inverse problem. Finally, a cross-correlation calculation was used to evaluate the direction of coupling and the strength between the cortical regions responsible for the initialization of discharge and their propagation. First, I displayed the active regions obtained by S. Loretta, MNE, and DSPM for all our databases. So the activation film shows that DSPM has the largest number of active zones and still has the most spatially extensive zones followed by S. Loretta and then MNE. We found that pure high frequency oscillation events show deep active areas that appear mostly by DSPM. After that, we computed network connectivity measurement with cross-correlation metric between active zones from our three types of events exploring our three distributed inverse techniques. After calculating the cross-correlation of the different events, we assembled a formation to evaluate our effective connectivity. First, we calculate the connection force between active zones of the entire inverse techniques by calculating the sum of the absolute correlation matrix, where we notices a great similarity between the connection strength of active zones of pure high frequency oscillation and HFO combined with spikes events for DSPM and S. Loretta. As a result, a high connection force rate is obtained by DSPM, then S. Loretta. After that, I have studied the crosstalk between the two hemispheres, right and left, for each inverse method and each type of events to assess left hemisphere interference with the right hemisphere. So, the crosstalk was calculated by the active region connectivity direction, where we tested the processing of the excessive discharge of the different parts of the brain. We can see these results obtained are in line with the neurological diagnosis of the patient studies. To conclude, in this study, we characterized the effective epileptic connectivity mainly of high-frequency oscillation networks from EEG recordings by exploiting at the beginning simulated data then realistic data formed by high-frequency oscillation to identify responsible areas of excessive discharge. And that we evaluated the power of three distributed methods of inverse problem DSPM as Loretta and MNE for the definition of epileptogenic zones. Therefore, all our results are very promising in studying neural alteration of effective connectivity. As another predictive directive, it is intended to make available measurement of high frequency oscillation effective connectivity from EEG and make registration and compare it to intracerebral EEG while applying other inverse techniques such as MEM. Thank you for your attention.